Hey guys, Drew up here, and welcome to the. Really should have counted. I think it's the ninth. It's the ninth or eighth. I seriously don't remember. But we're back again here in the Java tutorial series for a 2D platformer, and we are going to finish up our platform here. Right now, we can jump on it and land on it, which is all nice and lovely. And even it can move, and we should move upwards with it at this stage of the phase. Though the only problem I could see is this greater than or this greater than 0. That's not going to work. So if we do go to platform, and I'm just going to make it move up and down real quick. So say I need a float temp equals 0. Temp is going to keep increasing with dt. I'm going to say position y plus equals math dot cosine of temp times 32. It'll move up and down plus or minus 32. That should work. Where is it? Oh, geez, is it moving fast? Let's do 2. What does 2 look like? Am I thinking of this wrong? There we go. Whee! So we can ride them up and ride them down. Although going up and down is a little weird. But it does move, and we do ride with it. So yeah. We still have the moving part of the platform. It doesn't really work the best. Of course, you don't want the platform to move down faster than you fall down, but we can also add in other things to make it so that he sticks to the platform better than he is currently. But yeah. But what we're doing today, is the main thing today, is that we are going to add in the collision for the sides and the bottom. Alright, so we can currently collide with the top, but if we collide with the side or bottom, it doesn't really work. And this should be a rather short and simple video. Hopefully. That's the plan with every video, honestly. Sometimes it's just not the case. But we need another if statement, and this one is going to be easy. I'm going to do greater than, so this should be the bottom side. And what we're going to do instead is just basically we're going to get rid of the ground, and it should work exactly the same. So if I come down here, oops, oh geez, am I teleporting up or what? Stop it. I can't get under it. Oop, there we go. Wow, do we teleport fast. So if my y is greater than their y, the distance should be the same, theoretically. It should be negative. Because his y will be better than my y, which will give me a negative number, which then we add a negative to this, and then we just get a really big number, which is not what we want. So what we can do instead is I'm going to flip this around, right? Because my my y is better than his y, and instead of subtracting, we're going to add the distance here, and that should hopefully fix it. So now, if we jump up, we collide with it, and we hit our head on it, which works just as you'd expect. Now we need to collide with the side, right? Okay. But we have a problem here because, well, how do we choose if we collide with the side or the top, right? How do we figure that out? And there's going to be, we got to do a little simple thing here is this, to figure out whether or not we're on top or bottom. And basically, we need to figure out which is closer, the X or the Y. Which, that should be fairly simple here. Let's see if do I still have GIMP open? I do, it's over here. So basically, what I want is, actually move this around here. This is moved. So the way we determine here is that we're gonna see where our y is, right? And if I do, this is small. There you go. So like, say like this. Boom. I'm gonna try and visualize this here for you. This is not exactly to scale or mathematically accurate picture, but imagine if we have it divided up into quads here. And basically, we'll decide whether or not we are on top, whether we're colliding with the top or the bottom, based on whether our center is in this region or in this region. That makes sense. So whichever one is further. So if we're over here, right, our x value is really close to the center. It's a lot closer than our y. So we're in, since it's less than, we're on top. And same thing over here. If our x is closer than our y, we're very close. And over here, our y's are very close, but our x's are very far apart, right? So that means we're over here, and then once again, whether or not it's greater than or less than can choose the side. So we need to see, okay, so we're less than this, and we're going to check to see if our x variable is shorter than our y, all right? So I need to put all this in a big if statement that says myc.get center x. So right, we need a center x minus mcy other c that get center x. And I'm going to absolute this. Is less than math.absolute of same thing but y. So if this is true, then we know that we're dealing with a top and bottom collision, right? So we're going to do that. But else, if this is not true, then we're dealing with a side collision. And we need to do a similar thing, where we take this, put it here, and this wrapping needs to stop. Go back up there. I don't want your lines of the wrap. Keep going back around. Go back. Alright. And so here, we need to change this to our x is less than their x, which means we're on the left. Or our x is greater than their x, which means our x would be on the right. Let's modify the top one first here, and then basically we'll just copy and paste it down below, maybe modify things. So when we collide with the side, we're not actually going to do anything to our fall distance or ground at all. That's not going to happen. But we need to know our distance, so this should be width. So we need half width, and we're going to subtract x and y's. And x. Now because my x is bigger than his x, actually my x is less than his, that's the proper way around, so we'll get a positive number. And then we will subtract our offset x and our position x and our center x with distance. And that should... the air. Oh, accidentally put a slash here. That should collide with the right. So if I come in here, oh, we're getting an interesting effect here. It's a little hard to detect because our object is so high in the air. Let me move him down a little bit here. Let's go to platform, and I'm going to move him down a bit. So 176, that should move him down so that he's on the same plane. And I'm going to move him over a little bit, so that should be 892. Yeah, should be plus 16. And there we go. So now if I come in here and I run into him, get a very interesting result. Am I still subtracting y from somewhere here? I feel like I am. Oh, it might be this guy. Is this guy running here? This guy shouldn't be running. Boom. Let's see what happens here. No, but you see I'm being pushed down? It looks like it's trying to push me underneath, which it shouldn't be. It should be I'm on the left here. Do not try and push me around here. Right, is this executing right here? The print line. Bottom. It shouldn't. Let's make the console visible down here. Whoop. No. Why is it shoving me underneath? And let's go back up here. I'm just going to paste the same thing and we'll see what it says. Nope. Okay. But this is working, right? When we collide here, obviously something is happening. It says bottom. But for some reason, our Y is changing. Do you see that? How our Y goes down? That is weird. Am I modifying Y somewhere? Oh, our center Y is being moved. That's why. There we go. So now when we run into the right, we do collide with it. Alright. We're having problems standing on it, as you can see. If we start to move away just a little bit, it does have a problem. This might be better if we do plus other seed, plus, yeah, how about my seed dot get half width? And this should see what that does. Because I want him to be able to stand on the block without being pushed off. So that looks like, kind of fixed our problem right there. And it moved, I had basically moved it over here. Okay. Okay, I see what's going on. Kinda do. I kinda see what's going on. This right here, we need to add on other C F height. That just gives us the same result. Huh. Because I want him to stay on it just a little bit. But, doesn't seem to be working as intended. So the problem is you can go further off than intended. So our Y is far away, right? So we're colliding with the top if our X's are closer than our Y. But the problem is we can go to a point where our X is no longer, our X is bigger than our Y. And we fall off the side. And over here, it happens basically as soon as we cross over. And because there's no collision on the left side, it kind of just pushes us off. Does this, hang on, I might be coming about this at a wrong angle. Let's make this longer. So let's make the width of it 64. And now, will I still collide with it? Oh, geez. So it only works as a square. We have problems. We have problems, indeed. So how can we determine whether or not we're in this axis? So we got a problem here of our X and Y's. It doesn't really work that way very well. Because here, our X is bigger than our Y, which will put us down as a side collision. Which we don't want. We're still on top. So how can we determine that? Basically, we need to know when our center crosses this kind of imaginary line right here that we drew. We need to know when we're on one side or the other. Might take a little bit of thinking here. Ew. Okay. Okay, well let's think about what we have here. So we know our center X is right here. We could try and expand it outwards. There's always a simple solution to things. Try not to overthink it. I may have to try and think of how we're going to do this better. Because this only works for if this was a perfect square. If we extend this out longer, our current method of trying to figure out if we're colliding or not doesn't very well work. One moment. Alrighty, I think I figured out a way we can do this. And what we'll need to do is we need to keep track of our last position. And simply put, if our last position, say we come in here, and so we come here. How do we know we're colliding here? Because we want to, like, if we just hit right there, that wants to be a side collision, right? How do we know that? Because our last position, we'll see that our distance on our Y is a collision, but our X is not. So we were colliding on the Y when we weren't colliding on the X in the frame before, and therefore we'll hit the edge. Otherwise, we'll land on top. Does that make sense? So we need to keep track of our... I just got rid of my player. we'll need to keep track of our last position, and then we'll do our calculation of where we should land based off that. So I'm gonna go back here. I'm gonna make a private int last center x, a last center y. So basically, we're gonna do that, and then I'm gonna say last center. No, actually, before we calculate the new one, that'll be where we can do this the best. So last center x is equal to center x, and last center y is equal to last center. Not last center. Last. It's equal to center y, and then we'll calculate the new one for this frame, and that's how we will keep track of where our position was last. Gears and setters, last position, boom. Now we'll go back to our player here. And we're going to do this collision detection here. So, we're not going to use this if statement, but we're going to use something similar. So, if our y's are colliding, right? So, if we go back to our physics here, we have our y collision, which is this right here. And I'm just going to copy this, because this is our y collision. So, player. Actually, we need the x collision. For this, because this will be the y. So let's go back to physics. We'll take the x collision, copy that, and then we'll go to player, and I'm going to paste it in right there. And now we just got to change C1 to other and C0 to mine. Right, and we'll see, did they collide? But we don't want center, we want last. Last, and that should do it. So now, when we come in, we collide, and we got it properly working. So that was all we had to do. So we can get all the way to the edge of our little block, and we still keep colliding. And we can have as long of a block as possible. So there we go. We have figured out how to do it, and I don't need it spamming bottom anymore. And then if I unlock our right side here, which plus that should work as well. But my right side's kind of shoved into the corner. I can't get to it. I got to move my platform. Let's Control Z and Control Z. Yeah, that should move it back to good spot. Yeah, now I can test the right side. So I come over here. I don't collide. Oh, geez. Okay. I obviously forgot to change the Y. This should be X. X, X, and X. Now we run it. Oop. Come inside. Oh. Plus distance. Hang on. Our distance is way too big here. So let's take a second, think what's going on here. So here's our distance that we should be away. Minus that. This might be actually minus. I don't think that's the correct answer, but we'll see what happens when I do that. Oh geez. Yeah, it's plus. Is it that I have to change this? Oh wait, these are Y's. I didn't change the X's to Y. That's why I thought it should have worked in the first place. So, and this should be half width and half height. So I'm going to copy this. And copy that. I didn't change the X and Y's. You got to make sure you change it to be the proper right one. So now, we now collide with this square on all boundaries. And we can interact with it nicely. We now have axis line bounding box physics with our colliding. So there we go. So I think that's good for this video. We got our platform here. Let's add some I'm gonna add in some more platforms here. Let's go to platform. I'm gonna say int x, int y. I'm gonna say this is x and this is y. Let's go back to game manager here. So this will take in let's see here. where's a good place? I'm gonna put platforms across here. So let me figure out where it is on the plane. So I'll put one right here. So that's 26, 7. So I'm gonna just type in 26 and 7 and 7. And I'm gonna multiply that by tile size, And let's add in a couple more. That might be too many, but I'm gonna go 8, right? Or are they 9? Are they 2 blocks big? 9, 32. That might be way too many as it is. So let's copy these out. All right, so let's get multiple platforms in here. Yeah, there we go. So now we can jump from one to the other. Oh, fall between them. You know, what normally happens with a platform. What else can we do here? Let's add another one in, but below it, plus 8. And make this 7. So, see what that looks like. So yeah, you can make an entire level with these boxes. Right? So we have these boxes, but you don't have to, I'm moving them like they're tiles right now, just so it matches up. But if I said move this 7, and instead of going 6 up, let's do 6 divided by 2. Something, no, actually let's do 6 times TS minus TS divided by 2. Which should make it like a half block. Right, up a little bit too high. 2 plus. So these two boxes are colliding, but they don't have code through. It happens when they collide, but so we can interact with these boxes like you'd expect. So there we go. We now have platforms that we can collide with. More of a platformer than we were before, I guess you could argue. But yeah. So yeah, guys, comment, rate, subscribe, and I hope you learned something. And thanks for watching.